John Maynard Keynes once said that the statistical probability is the lamp that enlightens in the darkness of uncertainty. During this video, we will go through the following sections. 1. Introduction to Preparation and Excel Environment 3. Excel's statistical functions. 4. Excel's probability functions. 5. Summary of sections learning content 6. Conclusions. Now let's come to the first part. Introduce. Probability and statistics play a crucial role in many aspects of life, ranging from weather forecasting to business risk assessment. Having a solid understanding of these concepts is essential for making informed decisions. Microsoft Excel is a widely used tool that offers various features to solve probability and statistics problems. With Excel, users can perform calculations, analyze data, and present results effectively. By utilizing Excel, we can work more efficiently and make better decisions in our daily lives. In this video, we will introduce you to simple and effective techniques for using Excel to solve probability and statistics problems. 2. Data preparation and Excel environment. Instructions on how to create new spreadsheets and enter data. Now, to master your knowledge, you need to know how to use Excel, a utility tool that helps us perform analyses. First, we will start from the beginning by creating a new spreadsheet in Excel and entering data. This will be the first step to performing statistical analysis and probability later. Step 1. Open Excel. Open Microsoft Excel on your computer. Step 2. Create a new spreadsheet. Create a new spreadsheet by clicking the Create New Spreadsheet icon or using the Ctrl+N. Step 3. On the toolbar, select Insert Identify Columns and Lines for your spreadsheet. The columns usually represent variables or data types, while the lines represent observations or data samples. Step 4. When the insert item appears, continue to select the table icon or press Ctrl+T. Step 5. Enter data. Enter the data into the spreadsheet based on the structure you defined in Step 4. Enter the value in the cells corresponding to the variable. After completing the above steps, you will get a table as shown. In this video, we will demonstrate the practical application of 7 distinct Excel functions, comprising 3 statistical functions and 4 probability functions. We aim is to enhance your comprehension of how these functions work in real-world situations by solving specific problems. Join us throughout the video to gain a deeper insight into Excel and probability statistics. Ensure that you have Excel open on your computer and a notepad at the ready as we delve into a wealth of insightful content. Let's dive right in and get started. Turning now to the 3. Excel's statistical functions. When approaching statistical problems in Excel, it is crucial to follow some basic steps to ensure the accuracy and effectiveness of the analysis process in this form of statistics. These steps are particularly important for experts in the academic domain who aim to convince their audience with a formal and creative approach. By adhering to these steps, one can guarantee a reliable and robust statistical analysis in Excel. If there is no data analysis in Excel, do the following. Step 1. Select File, Options, Add-ins in the Manager box, select Excel Add-ins, and select Go. Step 2. In the Add-ins dialog box, select Analysis Toolpack and click OK. After completing the steps above and installing data analysis in Excel, we will move on to the main section, which includes the statistical functions that our team will use, along with accompanying examples to help you gain a better understanding. Come on, let's learn a tool of Excel that performs descriptive statistical functions. Descriptive statistics is an important part of statistics, used to describe, synthesize, and understand basic information from data or observation data. Descriptive statistics systematically synthesizes data, helps understand important characteristics of the dataset being studied, and helps identify trends, distribution, and variation in data. And come up with an example based on the actual data we found. The statistics describe math score, literature score, English score in the 2023 high school entrance exam of 100 top students in Ho Chi Minh City. To implement descriptive statistics, we need to take the following 2 steps. Step 1. Go to the Data tab at Group Analysis in Data Analysis dialog box. Select Descriptive Statistics and click OK. Step 2. At input range, we select the data area to statistic, at grouped by select columns, because the data is in columns. Next, we select labels in first row, if any, and summary statistics. Then at output range, select any blank cell to display the result. And finally, we select confidence level for mean, if necessary, confidence interval statistics, and click OK. And from the result table, we have the parameters. From the above parameters, we have the following comments. For the mean parameter, it can be seen that English has the highest average score. Literature has the lowest average score. For median and mode parameters, we see the English with the most outstanding points, followed by maths, and finally is literature. In addition, the student's score is quite uniform. There is no difference too large through the parameters. Dispersion, sample variance, the standard deviation is relatively low and small. The reliability with a probability of 95% parameter. The student's score may be in the range. Mathematics is from 9.2, 9.4, literature is from 8, 8.2, and English is from 9.7, 9.8. Based on calculation, mean plus confidence level. From the recent comments, we have a conclusion. Through statistical results shows that the top 100 students in Ho Chi Minh City in the 2023 high school entrance exam have very high scores. Maths and English subjects have a better score than literature subject. 3.2. T-test function. T-test, to sample, assuming unequal variance. The t-test function is a statistical function that helps you compare the averages of two datasets. It is used to check whether two datasets have the same mean. Example: investigate the income levels of 24 households in a month during the COVID-19 period and after the pandemic has subsided. We have the following dataset. With household income following a normal distribution, examine the difference in household income using a t-test with a specified level of confidence. Referred M1 to as households income during COVID period. Referred M2 to as households income after COVID period. With the given reliability, we need to test a pair of hypotheses as given below. Step 1. Go to the Data tab and choose Group Analysis. Then click Data Analysis dialog box and select T-test, to sample assuming unequal variance, and click OK. Step 2. Select the items as shown in the image below. In the Variable 1 range box, we select the data area to statistic, specifically in the Income during COVID area. In the Variable 2 range box, we select the data area to statistic, specifically in the Income after COVID area. Select labels in first row, if any. In the alpha box, we enter the alpha given meaning level. Assuming the significance level alpha is 0.05, we enter at output range. Select any blank cell to display the result, click OK. Step 3. From the result table, we have the parameters. I have t equal to 0.82, 2 smaller than 2.014, reject h1, and accept h0. Conclusion. So it cannot be said that household income during and after the COVID-19 period is different. 3.3. Anova function. The Anova function in Excel is a statistical tool used to compare the means of multiple datasets. It is employed to determine whether these datasets have the same mean values. Example: based on the NBC News visualizations and data analysis article from NBC News, conduct a one-factor Anova analysis for climate change data across multiple countries using the dataset provided. With the given reliability, we need to test a pair of hypotheses. Step 1. Go to the Data tab, then Group Analysis, Data Analysis. Select Anova, Single Factor, and click OK. Step 2. Select the items as shown in the image below. Step 3. From the result table, we have the parameters. The statistical value f greater than the critical value f crit, thus rejecting h0 and accepting h1. Conclusion. There is a significant difference in temperatures among countries. The average temperature in Canada is considerably higher than the average temperatures in the United States, Russia, and China. Next, we come up with Excel's probability functions. Come to the first function, Norm.dist. The Norm.dist function is used in Excel to calculate the cumulative probability or the probability density function for a given value in a normal distribution. Formula: Norm.dist x mean standard underscore dev cumulative. We have arguments. X is the value for which you want to calculate the probability. Mean is the average of the distribution. Standard underscore dev is the standard deviation of the distribution. Cumulative is a logical value that determines if the cumulative argument is set to true. The Norm.dist function returns the cumulative probability that a value in a normal distribution is less than or equal to the given value. If the cumulative argument is set to false, the Norm.dist function returns the non-cumulative probability or the probability density function, PDF, at the given value. Now let's proceed with an example. According to Advertising Age, the average base salary for women working as copywriters in advertising firms is higher than the average base salary for men. The average base salary for women is $67,000, and the average base salary for men is $65,500. The data is sourced from Working Woman, July-August 2000. Assume salaries are normally distributed, and that the standard deviation is $7,000 for both men and women. A. What is the probability of a woman receiving a salary in excess of $75,000? B. What is the probability of a man receiving a salary in excess of $75,000? C. What is the probability of a woman receiving a salary below $50,000? To solve this example, first, let's summarize the given data and input it into Excel. A. By subtracting the cumulative probability from 1, we can find the probability of a value greater than $75,000. Step 1. In cell B6, we enter the function =1 Norm.dist 75,000 B2 B4 true. Step 2. Enter and get the result as shown in the image. B. We can use the same approach as in part A. Step 1. In cell B7, we enter the function =1 Norm.dist 75,000 B3 B4 true. And step 2. Enter to get the result. C. We can directly use the Norm.dist function with a cumulative argument set to true. Step 1. In cell B8, we enter the function Norm.dist 50,000 B2 B4 true. And step 2. Enter to get the result. We come to the next probability function is Binom.dist. The Binom.dist function in Excel is used to calculate binomial distribution. Binomial distribution is the probability distribution of a discrete random variable with two possible outcomes, called success and failure. Formula: Binom.dist, number S trials, probability S cumulative. We have arguments. Number underscore S is the number of successes in trials. Trials is the number of independent trials. It must be greater than or equal to 0. Probability underscore S is the probability of success in each trial. Cumulative is a logical value that determines the form of the function. It can either be true or false. Is true when using the cumulative distribution function and is false when using the probability mass function. To better understand, we come up with an example. 12% of all cars on Brighton High Speed exceed the speed limit. If 20 vehicles on this road are selected at random and their speeds are recorded by radar, find the probability that A. 3 exceeded cars the speed limit. B. At most 3 cars exceeded the speed limit. First of all, we need to enter data into spreadsheets. A. Step 2. In cell B6, we enter the function Binom.dist B2, B3, B4 false, and step 3. Enter to get the result. And sentence B. Step 2. In cell B6, we enter the function Binom.dist B2, B3, B4 true, and step 3. Enter to get the result. 4.3. Poisson function. The Poisson distribution function in Excel is used to calculate the probability of a discrete random variable having a specific number of successes within a given time or space. Formula: Poisson, x mean cumulative. We have arguments. X is the number of events. Mean is the estimated value in numeric form. Cumulative is a logical value determining the form of the resulting output. Example: the number of customers entering a department store in an hour is a random variable that follows Poisson's function. A. Find the average number of customers entering the department store in 1 hour. B. Find the most likely number of guests per hour. C. Find the probability that at least 10 guests enter in an hour. Collecting data on the number of visitors to a department store during the day from 7 a.m. to 10 p.m. in Batavia, East Indies, Netherlands, we are given the following data table. Calculate the average number of customers entering the store in 1 hour. This is called the number of customers in an hour. Step 1. To calculate the average value of guests in 1 hour, we use the function average. Select one cell to calculate the average value. In the table here, we select cell B18. We enter the function =average B2 B16 and press enter. We get the value x = 16.73. Suppose x is a Poisson distribution, where x = p, lambda in it. Lx = 16. 73 = 17. B. Find the maximum capacity of customers entering the store within 1 hour. To calculate the probability of a K customer entering the store in 1 hour, for Poisson distribution, we have the equation below. In Excel, we can use the function Poisson.dist. We calculate the number of guests entering in 1 hour will range from 0 to 30 guests. Step 1. In Excel, we make a spreadsheet with x equal to k, the column of the number of customers to the store in 1 hour, and the probability column px equal to k, and px smaller than or equal to k, the corresponding probability column. Step 2. In cell B2, we enter the function Poisson.dist, a 2, 17, false, and press enter. The result will show 4. 13,994 E07, that is Iowa. Step 3. Continue to check box B2. Scroll down to the end of cell B32. We get the probability values from px equal to 1 to px equal to 30. Step 4. We need to rearrange the probabilities in order from low to high, or from high to low. Select a cell in the column to sort. Specifically, we select cell B2. On the Data tab, in the Sort and AMP filter group, click from A to Z to sort in ascending order. The Sort Warning dialog box appears. We select it as the drawing and click Sort Results Display. Looking at the spreadsheet, we can see that the most likely number of people to enter the store is 17 people respectively. C. To calculate the probability of no more than 1x equal to k customer entering the store, we still use the Poisson.dist function. Step 1. Press DRTL plus Z. To return the spreadsheet to the column order x equal to k displayed from 0 to 30, step 2. In cell C2, we enter the function Poisson.dist, a 2, 17, true, and press enter. The result will show 4. 13,994 E07, that is. Step 3. Continue to check cell C2. Scroll down to the end of cell B32. We get the probability values from px smaller than or equal to 1 to px smaller than or equal to 30. In cell C3, we see the result showing 7. 45,189 E07, that is to calculate the probability that there are at least 10 guests in an hour, that is, no more than 9 guests in an hour. Now we come to the final probability function in today's video, which is the Prob function. The Prob function in Excel is a statistical function used to calculate the probability of an event within a set of events with different likelihoods. It is used to compute the probability for a discrete random variable, calculating the probability of events falling within a specified range or equal to a specified value. Formula equal sign. Prob x underscore range, prob underscore range, lower limit, upper limit. We have arguments. X underscore range is a set of values representing different events. Prob underscore range is a set of probability values corresponding to the events in X underscore range. Lower underscore limit is the lowest value of the range for which you want to calculate the probability. Upper underscore limit is the highest value of the range for which you want to calculate the probability. If no lower underscore limit and upper underscore limit values are provided, the prob function calculates the probability for a specific event. To understand more about this function, let's consider the following example. Example: one day, I found a deck of cards on the side of the road and checked to see if it had 4 of each card. I discovered that it was missing all the face cards: ace, king, queen, jack, 3 3s, 1 4, 2 5s, 1 7, and all 4 9s. I decided to walk down the street and ask people what card they thought I had drawn. One woman said, "I believe it is between the values of 6 and 8. What is the probability of this?" Use the Prob function in Excel to calculate. To solve this problem, let's follow these steps. Step 1. Enter the data in columns. Step 2. In cell D2, we enter the function =, prob opening bracket. Select the range of cells from A2 to A10, comma, select the range of cells from C2 to C10, comma, 6, comma, 8, closing bracket, and press enter. Step 3. Get the result as shown in the image. In conclusion, 44% is the probability that she correctly guesses which card I draw. That concludes the final function formula in today's video. Let's now proceed to the conclusions. On the journey of exploring the world, humans always confront uncertainties. Throughout the practical work and research that led to this video, our team has recognized that statistical probability is a valuable tool that helps us gain a deeper understanding of these uncertainties. Thanks to this subject, we can make more accurate predictions about future events. Furthermore, we can use statistical probability to make more effective decisions in our daily lives. It can be said that statistical probability is a subject with wide applications in various aspects of life. If we learn it well and master it, we hold a significant key to success in both our current and future lives. In conclusion, our team would like to express our sincere gratitude for taking the time to listen to and watch our video. We wish you a joyful and fulfilling day.